Hello, welcome back to our last video on motion. So, before starting that, let us have in our last class. We have studied right hand rules. This is a pending work which we have to do. Then, what is meant by cross products? So, cross product we also call it as a vector products. So here in this part, as I said, the A cross B, you can write it as AB sine theta into C crown. So A cross B, you can write it like this. So this we call it as the cross product, and the cross product can also be called as a vector product. Then we have studied the cross products can be written it like A cross B, B cross A is equals to minus A cross B. And if I have two same A, that if A is equals to B, then A cross A is equals to A square and sine 0 is 0. So as a result, if I am having two same vectors, so my value comes out to be 0. This is 0 vector. Now cross product, this is also an homework which is to be done, and this one is a example problem which we have solved, and I cross J is equals to 1 and that is equals to K. Then J cross K is equals to I, and again K cross I equals to J cap. Then we have we have solved these unit vectors and they are represented in the determinant. Then when I am having the vector C, and if I am taking the square, so C is equals to square root of A square plus B square plus 2AB cos theta. And if I want to represent in direction form, so tan phi is equals to B sin theta upon A plus B cos theta. Then we had this one example, and then we have studied the definition of displacement, what the displacement is, how the object moves from one point to another, and what the displacement exactly means. And then we have started the scalar form of displacement, that we call it as a, and the unit for the displacement was meter. Then we have velocity, the dx by dt, you can write as a delta x upon delta t is equals to x2 minus x1 is equals to d2 minus t1. So that is velocity. Velocity is also again a vector quantity. The SI unit of velocity is meter per second. Circular motion. So and the motion which repeats after regular interval of time, we call that as uniform circular motion. Fine. So if we'll take the examples, the revolution of earth around the sun is an example of circular motion, uniform circular motion. Why? Because it repeats its motion after every 365 days. Okay, same way the revolution of moon around the earth is also an example of uniform circular motion, because the motion repeats after regular interval of time. Okay, now here in this part, just see this diagram. Now in this diagram, this is my x-axis, O is the origin, and this is my y-axis. Okay, now what has happened? Now I am having a point A, okay, and this is a point P. This is in a circular form. So the coordinate for point P is xy. In a geometric form, the coordinate for the point P is xy, and the distance of P from O is denoted by r. Okay, if I draw an imaginary line, if I'll extend it perpendicular, so that comes out to be 90 degree. ठीक है. So by trigonometry we are getting an angle here AOP, and the value of that angle is theta. So that's been written as theta. Now here in this part, what is the value of x? This x, we have done this topic before. X is equals to r cos theta. This r and this cos, this theta. So cos theta will be equals to x by r. So as a result, x is equals to r cos theta. Similarly, here this is a y. This part will be y. So what is y? Y is equals to r sin theta. So we have got the value of x. X is equals to r cos theta and y is equals to r sin theta. Clear? Up till here it is clear. Now here in this case, the angle, this angle, it's been given by the particle, means a particle is moving from here till here. Okay, so here in this part it's moving from here till here, so it's like a displacement, right? So displacement, so that displacement is denoted by theta. We know the formula of speed. Speed is what? Distance upon time. So this theta comes out to be distance upon time, and this W like symbol is called as omega. And what is this omega? Omega we call it as an angular speed. ये ऐसे सर्कल जब आता है और उस सर्कल्स में जब हमें स्पीड बतानी होती है, सर्कुलर शेप में जो स्पीड बतानी होती है, तो उस स्पीड को हमें रिप्रेजेंट करने के लिए जो सिंबल यूज़ करता है, तो उस स्पीड को हम लोग बोलते हैं एंगुलर स्पीड. सो दैट थीटा इज इक्वल्स टू ओमेगा टी. Is clear? Now what we are going to do in this expression, x is equals to r theta, so that I'll write it as r omega t. This is w here, this is omega. Now again y is equals to r sin omega t. Fine. So now just from this diagram we have found out two things. One is x is equals to r cos theta, and similarly that theta substitution we have done till now. I hope it is clear till now what we have done. नेक्स्ट, नाउ वी हैव गॉट द वैल्यू ऑफ एक्स एंड वाई. तो अगर हमें यहाँ कोई बोलेगा ये पॉइंट पी है, पी को वेक्टर फॉर्म में रिप्रेजेंट करो, ठीक है. सो व्हाट इज पी? दिस इज आर इज व्हाट? एक्स आई कैप प्लस वाई जे कैप you have to write. Now what is x? X is equals to r cos omega t, and what is y? R sin omega t. So see that r is equals to r cos omega t I cap plus r sin omega t j cap. So this is the displacement of a particle in a circular path. Now what about velocity? Velocity is what? d by derivative of r. So v is equals to dr upon dt, which is equals to, अभी इसका डेरिवेटिव निकालना है. What is cos? Derivative of cos will give minus sign. So here I'll derivative of this cos, I'll get minus r sin omega t. See here in this part we are taking out the derivative of cos omega t. So here it will, cos omega t will become sin omega t minus sin omega t. Again the derivative will go to omega t. So that's the reason we'll get omega outside. Okay. Then plus again same here sin omega t. Sin omega t is what? Cos x. So here we are getting it as r. Again same d by dx of sin omega t will give me cos omega t. And then again derivative of omega t will give us omega. So this way we will be getting the expression for velocity. Now this we can write it in a simple form as Vx, and this we can write it as Vy. So what is Vx? Vx is nothing but minus r omega sin omega t, and Vy is r sin or r omega cos cos omega t. This is wrongly written as a, it's omega t. Okay, now we'll go to next topic is acceleration. Now we have determined the displacement, that is the position vector. Then we have determined the velocity. Now next, acceleration. Okay, so but before going for acceleration, we'll determine the magnitude of velocity. So velocity is v is equals to square root of vx square plus vy square. Before starting this, I'll just take a differential formula. Sin square t plus cos square t is equals to 1. दोनों का term sin square t plus cos square t is equals to 1. Fine. Now come back to this. So we substitute vx square. So vx is r square omega square. Then this term, दोनों भी टर्म का r स्क्वायर ओमेगा स्क्वायर कॉमन निकलेगा. इसका साइन स्क्वायर ओमेगा टी, इसका कॉस स्क्वायर ओमेगा टी. तो साइन स्क्वायर और कॉस स्क्वायर का क्या बनता है 1. सो वी आर गेटिंग 1 एंड स्क्वायर रूट ऑफ r square omega square. So nothing but r square omega square and square root, and that is r omega. So v is equals to r omega. This proof is clear. Okay, now what we will do is that if we multiply v dot r, so v dot r, so what is the value of v, which we have learned in our previous slide? So that was minus r omega sin omega t I cap plus r omega cos omega t j cap, and this is a term for r. So that is r cos omega t I cap plus r sin omega t j cap. So this, I'll open the brackets, this term multiplied with this term multiplied with this again, and then this term multiplied with this, and this term will be multiplied with this, and these are the remaining terms which I'll be getting it after solving this term. So here in this part I'll just get r square omega, then cos omega t and cos omega t plus r square omega cos omega t and sin omega t is equals to 0. Now here in this part, you know, v dot r is equals to 0. It is equals to 0. Why? V is always perpendicular to r. Velocity जो है वो radius से perpendicular होता है. ठीक है. Now we'll go to our expression, that is acceleration, which I told you before. Acceleration is dv by dt. So we know v का formula. So we'll substitute that v here. So here in this part ar. So let us say ar is a radial acceleration. So here in this part ar is equals to minus, where is that term, this, minus r omega square cos omega t I cap minus r omega square sin omega t j cap. Now here how it came out to be omega square. We got it omega square because previously we had omega, and again if I finding out the derivative, so again derivative will give me one more omega, so that's the reason we are getting it as omega square. Now what we'll do, we'll just take out omega square as common from all these brackets and see what we are getting. So that is r cos omega t I cap plus r sin omega t j cap. This is nothing but r. So we'll just substitute it as r. So what we are getting is ar, acceleration, is equals to minus omega square into r. I hope this up till here it is clear. We have derived a vector component for r, we have derived a vector component for v, we have determined the velocity in terms of magnitude form, we have determined an expression for the acceleration, and acceleration a is equals to minus omega square into r. Now this expression ar is equals to now omega square r. ठीक है. Now in this case omega, you can write what is omega. Omega is equals to v by r. So here v square upon r square dot r, so which is equals to v square upon r. ठीक है. So till now which all formulas we have learned? V is equals to square root of Vx square plus Vy square and Vy square, and then we have the formula for acceleration. Acceleration is equals to minus omega square r, and ar is equals to over v square upon r. Now examples of uniform circular motion. Now what is that example and how is this example? Now this is a satellite. Fine. This dotted line is a satellite. Now this satellite is at a distance h. मतलब satellite usually we say it at it's above the surface of the earth. So that's the reason we denote it as h. And this r is the radius of the earth. Now what we have to say that the satellite in a circular equatorial orbit. Now this thing is clear. The acceleration due to gravity is denoted by g dash. Now we know in the previous proof only we just proved that a is equals to v square upon r. So here in this part g dash, or acceleration due to gravity for the earth, so it comes out to be g dash is equals to v square upon r. So you can write it as v square is equals to g dash of r. Okay. Now angular speed of satellite. So what we are getting is omega square r square is equals to g dash into r. V square का substitute किया. V square is what? R omega. So v square omega square is equals to g dash into r. So we are r getting cancelled. So we are getting as omega square is equals to g dash upon r. Okay, up till here it is clear. Now we are going to tell you the formula for time period. Time period is equals to 2 pi upon omega. This is omega, which is equals to 2 pi square root of r upon g dash. And what is this r? R is r plus h. ये टोटल r है, यहाँ से यहाँ तक का जो है ये r है स्मॉल r, ये r और दिस r plus h. ठीक है. Now what is this r? Capital R is the radius of the earth, and this h is the height above the surface of the earth, to which height the satellite is being drawn. Okay, or we'll say the height above the surface of the earth. Now here in this case, the time period, if we want to determine the time period, the satellite take to complete one orbit around the earth, means वो अर्थ को गोल घूमने के लिए उसको कितना टाइम लगता है अगर वो कैलकुलेट करना है तो. सो t इज इक्वल्स टू 2 पाई दिस वन. अब इसका अर्थ का रेडियस कितना है? 6.37 इंटू 10 टू पावर 6 प्लस 0.17 इंटू 10 टू पावर 6. ये हाइट का हो गया, ये हो गया इसका रेडियस का, डिवाइडेड बाय जी डैश. एक्सेलरेशन ड्यू टू ग्रेविटी का भी जो सब्सटीट्यूशन वैल्यू दिया होगा एग्जाम में, तो स्पेसिफिक वही यूज़ करना, कोई और मत यूज़ करना. सो हियर इट विल बी 9.26. The value of g dash will be given as 9.26 meter per second square. So substituting this and calculating, we are getting the value of time period as 5.28 into 10 to the power 3 seconds. That is 1 hour 28 minutes. So this is just a simple examples of uniform circular motion. So uniform circular motion, what example which I have given, earth and the satellite. So this is that example. So we just have performed this calculation to determine the value of time period. That's it. Now relative velocity. What is meant by relative velocity? First of all, see this diagram. Now I am having a point P, I am having a point Q, starting from O. So a person starts from here, it goes till here. He starts from here, it goes till this. So in this case, what has happened? Both are in different directions, but the OP is being denoted by RP and OQ is denoted by RQ. So now by the, as this arrow is going up, this arrow is going up, so I'll just join this line, so this become RQP. So RQ वेक्टर एडिशन का, लॉ ऑफ एडिशन ऑफ वेक्टर्स का अगर हम लोग फॉर्मूला यूज करते हैं तो उसके बेसिस से RQ, ये RQ प्लस RQP इज इक्वल्स टू RP. सो RQP अगर निकालना है तो RP माइनस RQ. ठीक है, तो हम लोगों ने रिलेटिव वेलोसिटी में हमारा R का वैल्यू दैट इज पोजीशन वेक्टर निकाला. अभी यहाँ पे भी वापस से हम लोग वेलोसिटी निकालेंगे और वापस से हम लोग एक्सेलरेशन भी निकालेंगे. ठीक है, तो रिलेटिव वेलोसिटी, ये जो टॉपिक है रिलेटिव वेलोसिटी, सो हाउ वी विल डिटरमाइन. सो एज वी नो RQP इज इक्वल्स टू RP माइनस RQ. सो what we will get, RQP is equals to d by dt of RQP. So RQP मतलब RP minus RQ. So drP upon dt minus drq upon dt. So this is nothing but Vp minus Vq. So VQP is equals to Vp minus Vq. ठीक है. नाउ लास्ट नॉट द लिस्ट, अब इसका एक्सेलरेशन निकालना हो तो एक्सेलरेशन निकालने के लिए हम लोग क्या करने वाले, वापस से वेलोसिटी का डेरिवेटिव निकालना है. सो dv by dt vqp इज इक्वल्स टू dvp माइनस dt माइनस dvq अपॉन dt. सो दिस इज नथिंग बट ap माइनस aq. सो दिस इज द फॉर्मूला फॉर द एक्सेलरेशन. This is for the velocity. So here in this case, if VQ is constant, then AQ will be 0 and AQP will be equals to AP. ठीक है, this is just notations which we have to know. तो relative velocity का मतलब यहाँ पे हमें clearly समझ में आया है, जे that is VQP is equals to VP minus VQ. ठीक है. नाउ रिलेटिव वेलोसिटी का एक एग्जांपल ले लेते हैं. इट्स ओके, थैंक्स फॉर वॉचिंग. इस यहाँ तक जो भी हम लोगों ने थियोरी टॉपिक्स कंप्लीट किए हैं, सो बेस्ड ऑन दैट वी हैव कंप्लीटेड दिस चैप्टर कॉल्ड एज. थैंक्स फॉर वॉचिंग.